Hey there, and welcome. Today, we're going to unlock what I think is a mathematical superpower, one that lets you measure just about anything in the world, from the tallest tree to the farthest star, without ever needing a ruler. I mean, how is that even possible, right? Well, let's dive in and find out.
But seriously, just think about it for a second. It sounds totally impossible, doesn't it? You're just standing there on the sidewalk, craning your neck to see the top of this giant building. How on earth could you figure out how tall it is?
Well, the secret isn't some crazy magic trick, it's just a triangle. You know, the second you look up at something tall, you've basically just created one without even trying. Your line of sight, the ground beneath your feet, and the object's height, they all connect. And the math that studies these little shapes, that's our key.
Okay, so let's get right into it. We're about to see why this particular branch of math is just so fundamental to how we understand and literally build the world around us.
And listen, this is not some newfangled idea. Just look at this quote. It's from 1890. That's incredible. So even way back then, people knew that trigonometry wasn't just some dusty, forgotten corner of mathematics. No way. It was then, and it absolutely is now, right at the heart of everything.
You know, the name itself pretty much gives the game away. You break it down, tri for 3, gon for sides, and metron for measure. 3-side measure. That's literally all it is. It's simply the study of this really predictable, super reliable relationship between a triangle's angles and the length of its sides.
All right, so if we're going to go around measuring the world, we're going to need the right tools, right? So let's open up what I like to call our trigonometry toolkit and see what's inside.
And here it is. This is the secret weapon. Every single one of these amazing calculations we're talking about, whether it's for skyscrapers or for distant stars, they all boil down to this one beautifully simple, surprisingly powerful shape, the right-angled triangle. You know, the one with that perfect 90-degree corner. Okay, tool number 1 is called sin, or sin for short. And don't let the name scare you. It's really just a simple recipe. All it means is this. For any angle you pick in that triangle, the sine is just the length of the side opposite the angle divided by the length of the longest side, which we call the hypotenuse. That's it, opposite over hypotenuse. Next up in our toolkit, cosine, or cos. And guess what? It's a very similar recipe. This time, it's the ratio of the side that's right next to the angle, we call that the adjacent side, divided by, you guessed it, the same hypotenuse. It's just another way of looking at the very same triangle. And our third and final tool for today is tangent, or tan. This one's a little different. It leaves the hypotenuse out of it. It just compares the two shorter sides. It's the length of the side opposite the angle divided by the length of the side adjacent to it. And believe it or not, that's it. Sine, cosine, and tangent. That's the whole shebang. That's our core toolkit. Okay, so we've got our tools. Now we need to learn the lingo for actually using them out in the real world. This is where things start getting really practical. So the first term you need to know is super simple, your line of sight. And it is exactly what it sounds like. It's that invisible, straight line that goes from your eye directly to the thing you're looking at. And that line? It becomes one of the most important sides of our triangle. All right, so using that line of sight, we can define two really important angles. When you look up at something, say the top of a tree, the angle that's formed between the flat ground and your line of sight, that's called the angle of elevation. And you guessed it, if you're up high looking down at something, that angle between the horizontal and your line of sight is called the angle of depression. Looking up, elevation, looking down, depression. Simple as that. Okay, we've got the tools, we've got the vocabulary. I think it's time we went back and solved that puzzle from the beginning. Let's put all these pieces together. So here's the challenge. Let's imagine there's a tower. We know we're standing exactly 15 meters away from the bottom of it. We take out a little tool, we look up to the very top, and we measure that angle of elevation, and it's exactly 60 degrees. The question is, how tall is that tower? So, how in the world do we solve this? Well, we don't panic, we just follow a few simple steps. First, let's just sketch the scene. And what do we see? A right-angled triangle, of course. Okay, step 2. Label what we know. We know the angle is 60 degrees. We know the side adjacent to that angle is 15 meters long. What are we trying to find? The height, which is the side opposite our 60-degree angle. So let's think. Which of our tools connects the opposite side and the adjacent side? That's right, it's tangent. So we just need to plug in the numbers, we do a quick calculation, and there it is. The height of that tower is 15 times the square root of 3 meters. Think about that. No ladders, no ridiculously long tape measures, just a little bit of clever math, and we've just measured the impossible.
Now you might be wondering, wait, where did you get that number for the tangent of 60 degrees? Well, this table here is kind of like a little cheat sheet for trigonometry. You see certain angles like 30, 45, and 60 degrees pop up all the time. They're special because they come from doing simple things like cutting a square in half diagonally or splitting an equilateral triangle down the middle. That's why their ratios are so neat and predictable. Honestly, these are the key values you're going to see over and over again.
Okay, so we measured a tower. That's pretty cool. But the power of this toolkit, wow, it goes so much further than that. Let's zoom way out for a second and appreciate the true scale of what trigonometry can do. And get this is what I find absolutely incredible. The very first people to work this stuff out, they weren't measuring buildings on Earth. They were ancient astronomers. They were using these very same ideas to figure out the distances to the stars and the planets. I mean, how amazing is that?
And today, that incredible legacy is stronger than ever. Trigonometry is basically the invisible engine running behind the scenes of our modern world. I mean, you need it for engineering bridges that don't fall down, for navigating planes and ships across the globe. It's even used to design the physics in your favorite video games, and of course, for all sorts of breakthroughs in the physical sciences.
So, from now on, when you look up at a tall building, or a huge mountain, or even up at the moon, I want you to remember that simple, invisible triangle that connects you to it. Because you now have the fundamental tools, that toolkit, to actually understand and measure the world around you. So the only question left is, what are you going to measure first?